I'm absolutely delighted that I was invited to come here and tell you all about what I hope to convince you is a very amazing, fabulous, beautiful, intriguing new cactus for Southern California. It's my great pleasure to introduce you to Cylindropuntia chuckwallensis, or as we like to call him, the Chucky Cholla. The story of the discovery of Cylindropuntia chuckwallensis began back in spring of 2011 when my esteemed cactus guru, Dr. Mark Baker, and I were working on a rare plant survey south of the Mule Mountains out in northeastern Riverside County. The Mule Mountains are just southwest of Blythe, California, which is right on the California-Arizona border, right where Interstate 10 crosses. The mules are directly east of the Chuckwalla Mountains, which will obviously become important real quick here. But for the purpose of the very beginning of this saga, what was really important was the fact that the Mule Mountains are directly north and adjacent to the Chocolate Mountains aerial gunnery range. As you probably know, the California desert has been used for military training for decades and decades and decades, and so there's all kinds of random military debris out there, including nasty things like UXO, unexploded ordnance, and other things. This survey was for a proposed solar plant, which fortunately did not make it past the permitting process, yay. And the company that we were working for is one of these very large multinational environmental and engineering consulting firms. And so they're very, very safety oriented or liability oriented, as you might call it. And so they figured, since we were working so close to the aerial gunnery range, that in addition to our usual morning talk, is safety talk, where they tell you to drink lots of water and wear sunscreen and don't step on rattlesnakes, that they would hire a couple of UXO specialists to come out and tell us every single morning that we should not touch or pick up things that looked like unexploded bombs or exploded bombs or just anything metal in general, basically. And so we were getting paid good money on this gig. So these guys would come out in their blindingly chartreuse shirts, and we would all stand and stare very, vividly at these things. But as it turned out, for whatever bureaucratic reason, the UXO guys were only allowed to work 6 days a week. Whereas, of course, botanists on a survey work 7 days a week over and over until you can't walk anymore. So the company said, well, we're afraid since the guys can't come out today, we can't let you work today. And we were all kind of taken aback by that. And they said, wait, but before you mutiny, here's the deal. Come up with 8 hours of botanically related work to do, and we'll pay you for it. So not our usual 10 or 12-hour days, but not a bad deal. So that morning we had a meeting, and we got all of our paperwork caught up and all of our GIS, CNDDB data sheets, got everything caught up, and then we went and had fun. So 5 of us headed out, and we were trucking along the north side of the Chuckwalla Mountains when we started to see this really strange-looking cholla. And Mark Baker said, well, what the heck is that? And we all said, well, Mark, isn't it just Cylindropuntia echinocarpa? Cylindropuntia echinocarpa is a very common species, very widespread, and it also has a great deal of morphological variation across its range. And as many of you probably know, if you get rodents getting under the roots of chollas, they'll fall over, they'll reroot, and you can end up with these big, ugly masses of decumbent chollas. So we figured that's just what was going on here. Well, he didn't buy it. He said, no, I don't think that looks like echinocarpa. I think we potentially have something new here. And we all said, okay, whatever, Mark. So we continued our little expedition. And later that afternoon, we were headed towards a place called Chuckwalla Spring, because of course you always find cool stuff in springs. And we walked up through this beautiful little red canyon here and turned the corner. And boom, we managed to find one of these things in flower. This was May 1st, 2011, so it was past the main part of the flowering season. This is the only individual that we found in flower on that day. And so Mark, of course, climbed up and proudly grabbed a few joints, including the flower, and he came down and shoved it smugly in our faces and said, does that look like Cylindropuntia echinocarpa? And we had to admit it didn't. So we started to believe that maybe we might actually have something new and undescribed here. So that began the whole fun saga of Cylindropuntia chuckwallensis. And our study of the species was divided into kind of two parts. We had surveys where we just basically went around and looked for the thing, and then we also did a pretty in-depth morphological study. As far as the surveys go, we started right where we found it, near Chuckwallensis Spring, and we just, over the course of a couple years, whenever we had time and money, we just drove around in kind of an increasing spiral to all these various little mountain ranges and stuff and looked for the thing. That was a lot of fun, as you might imagine. One of the first places we went was a place called Corn Spring here, pretty much in the heart of the Chuckwalla Mountains. And the reason we went there, besides the fact that it's in the heart of the Chuckwallas, is that it's easy to get to. Okay? Botanists have been doing that for pretty much forever. And the first time we went to Corn Spring, we showed up after dark. There's a campground there. And we woke up in the morning and we found ourselves absolutely surrounded by the mystery cholla. So we pretty much hit the mother lode really early on. We were very excited about this, needless to say. As far as the morphology study goes, we basically wanted to see if we could actually separate out what we are by now calling the chucky cholla from other morphologically similar chollas. And so what we did was we went around all over California, Nevada, maybe in a little bit in Arizona. I'll show you a map in a second. And we looked at, we measured 4 populations of Cylindropuntia chuckwallensis, a total of 125 individuals. And then the second one that we looked at was Cylindropuntia multigeniculata. Not very many people know about this one. It's a rare cholla that occurs mostly in southern Nevada. It gets down a little bit into northwestern Arizona as well. And the reason we chose this one, even though the two species are geographically very far apart, they do not co-occur or even come close to it. A multigeniculata, as you can see, morphologically is very similar looking to chuckwallensis. So that's why that was included. And then, of course, we looked at Cylindropuntia echinocarpa for the obvious reason that that's the one that you're going to mistake it for. So chuckwallensis and echinocarpa do co-occur. In the case of echinocarpa, we measured 4 populations and 123 individuals. And then the fourth species was our statistical outgroup, and we chose Cylindropuntia echinocarpa for 2 reasons. One, it makes a good outgroup because you're not going to mistake it for chuckwallensis. It really looks nothing like it. But also, we have this vague thought that it could possibly be an ancestral species to, or an ancestor of chuckwallensis, because it shares with chuckwallensis the characters that I'll talk a lot more about here real soon, in that it has this red pigmentation both in the filaments and in the style. And the floral color, the tepals, range from a fairly pale yellow to a pretty dark red maroon. And for echinocarpa, we looked at 4 populations, 120 individuals. For every single one of these 400 whatever individual cactus, we measured 13 characters, and each of these characters were measured 3 times per plant. So basically, we ended up with a gigantic pile of data, which we then put through multivariate analysis of various types, discriminant function analysis, MANOVA, all sorts of fun things, to see if the species, all 4 of the species separated out, and specifically to see if chuckwallensis separated out nicely from the others. This is where we did our morphology measurements. We tried for each species to choose populations that spanned the range of the species, so that we captured the most morphological variation, the most possible variation for each species. And our results. Here's our results for our survey. This is where we found Cylindropuntia chuckwallensis in these little pockets. Farthest south we found it is in the Chocolate Mountains in northern Imperial County. This is actually technically on the gunnery range, but there's a road that you can actually drive through the gunnery range as long as you don't go more than about 3 feet on either side of the road. They won't come after you with tanks and things. Chuckwalla Springs, where we originally found it, Corn Springs, where it's thick on the ground, over here in the Oricopias, and then all the top 3 there are all in Joshua Tree National Park. We excitingly, just as of a couple months ago, we have a new dot on the map, which is like up here somewhere. A couple of friends of ours on a tortoise survey crew at 29 Palms Marine Corps Air Ground Combat Center found some. And one of them grabbed a stem for us, and the other one took some photos. It was in flower. There's absolutely no question that it's Cylindropuntia chuckwallensis. So that's a new county record, because that's San Bernardino County. It's about 40 miles north of the smoke tree well population. So we were pretty stoked about that. We have inquired as to getting permission to get out there and crawl around in the hills near where they found it to see if we can find more of it. We have not heard anything back. Dealing with the military can be interesting. I did it for a long, long time. And both Mark and I have worked on 29 palms before, but they haven't been responsive so far. Maybe someday we'll get out there and get to see it. The morphology results, as I said, it was a gigantic pile of data, which resulted in a gigantic pile of results, and nobody likes to look at gigantic tables of results. So I boiled it down to what I think are the most important characters for if you are actually trying to go out and determine whether what you're looking at is chuckwallensis or echinocarpa. And of course, all 4 of the species separated out statistically. That was great. And chuckwallensis differed from echinocarpa actually in 7 categories, but the other 3 all have to do with the tubercles, and I figure nobody's going to be out there with a measuring stick measuring tubercles to try to figure out which species they're looking at. So I boiled it down to the ones that you can see with easily. And they are, first of all, internode length. Chuckwallensis has a significantly shorter internode length compared to echinocarpa, about 3 centimeters versus 9 centimeters. That's just the stem length between branches, basically. And then branches per node, so how many stems come off at each node. 4.5 for chuckwallensis, 2.4 for echinocarpa, so significantly more for chuckwallensis. And then on the central spines, the thickness both of the spine and of the spine sheath, significantly more narrow in chuckwallensis compared to echinocarpa. So the overall picture that you get when you're looking at a chuckwallensis versus an echinocarpa, due to these 4 big differences, is that chuckwallensis looks very dense, very compact, and due to the thinness of the spines, it generally looks very, very white, very pale. As you probably know, one of the more common names for echinocarpa is golden cholla, because it has these fairly thick spines that are generally yellow, thick sheaths, and so it tends to give the overall plant this kind of golden hue. Of course, that's not hard and fast because echinocarpa is such a widespread and variable species. There are plenty of populations out there where, another common name for it is silver cholla, and they look silver. There are populations where it looks pink. But anyway, if you see this, if you're in the chuckwallensis range and you see something that looks like a spiny little cloud floating along the ground there, you may very well be looking at a chuckwallensis. And if you see it anywhere that is not on the map that I showed you, please let me know, because we're always looking for more, and we know it's out there in more places that we just haven't had a chance to get out to yet. Come on. Now, if you see it in flower, you will not have a problem distinguishing it from Cylindropuntia echinocarpa, unless by chance you get one of the very few individuals, less than 3% of the ones we measured, that are very, very pale yellow flowers and do not have any real distinguishable pink to red pigmentation in the filaments or style. But the first time we went to Corn Spring when this thing was actually in flower, we were just, of course, blown away. How can you not be? Absolutely beautiful flower color range. They look so beautiful against that kind of stark white needle spines. Just really, really cool. So while we were doing our morphology study at the time we were there when it was actually in flower, I was taking data at the same time on flower color. And this is about how it fell out. A little over 10% yellow, a little over half orange, a little over a third red. Obviously measuring color is very subjective, but I did my best. I just said, is this more yellow, more orange, more red? And that's how it came out. As we were looking at these flowers, we very quickly realized that we also had some really interesting floral morphology variation going on. And what was going on was that in about 62% of the plants, they had perfect flowers, where you have these nice, big, happy anthers filled with pollen. Got a little pollinator there with some gigantic pollen sacs on his legs. Everybody's perfect and happy. And then about 40% of the plants had these really wimpy, pathetic, shriveled up white anthers that produced no pollen, making these plants effectively female. So this is a form of dioecy. You kind of have a spectrum in plants, right? On one end, you have dioecious plants where you have separate male and female plants, okay? You've got male flowers on this plant, female flowers on this plant. The other end of the spectrum, everybody's perfect. Everybody's got perfect flowers. But then you've got all this possibility in between. And when you have the situation where you have individuals with perfect flowers and some individuals with effectively female flowers, that's called gynodioecy. So now we have this wonderful, we have something that we know is morphologically distinct, can be determined even when it's not in flower. We have this beautiful color variation with these red filaments and styles, and now it's gynodioecious as well. Well, this being Mark Baker, he whipped out his handy field scope, grabbed some buds that were still undergoing meiosis, so the pollen was not quite yet pollen, and paraphrasing, he said, "Wow, there's a boatload of chromosomes in there." That's not exactly what he said, but so he went around and he found a bunch of buds that were in the proper state of meiosis and took them home and did actual full squashes on them and counted the chromosomes, and every single one of them turned out to be hexaploid. 2n equals 66. Normal in Cactaceae, of course, is 2n equals 22. So this was a really good day in the field. We now pretty much knew it was a slam dunk that this was a new undescribed species, so we were very, very happy. So with this, Cylindropuntia chuckwallensis entered what I like to call the elite gynodioecious hexaploid Cylindropuntia club, because it's really fun to say. It's the northernmost of these 4 species. To the south, we have Cylindropuntia wolfii, which occurs in San Diego and Imperial counties, the southern part of Anza Borrego Desert State Park, and the mountains to the west of there along Interstate 8. You can see tons of these guys. Down into Baja, and wolfii gets a little bit into Baja as well. Down farther in Baja, we have Cylindropuntia sanfilippensis, not surprisingly, around San Felipe. Farther down Baja, we have Cylindropuntia calmalliana, and that gets down into Baja California Sur as well. All 4 of these species are morphologically distinct from each other. If you know your choias at all, you're not going to mistake any of these 4 species for each other. However, they all share that same flower color variation of pale yellow to very, very dark red, and they all have the pink to red pigmentation in the filaments and styles. So obviously there is some interesting evolutionary stuff going on here that we have basically no idea about at this point. We're very hopeful that in the next several years we will get a chance to get out and do some genetic work on it and maybe figure out what's happening with these really awesome plants. So a quick look at the other 3 members of the elite gynodioecious hexaploid Cylindropuntia club. This is Cylindropuntia wolfii down in the, well, it's actually south of Anza Borrego Desert State Park, obviously near the new Ocotillo Wind Farm, which everybody loves to hate, including me. Cylindropuntia wolfii is a very handsome, robust, big cholla, really nice looking. And this, in a couple months ago when it was in flower, I went out there and I did the same thing with the flowers that I did with the chuckwallensis, in that I looked at perfect flowers versus female flowers, and I also looked at the flower color. And I didn't put the numbers up here, but the numbers were remarkably similar to chuckwallensis, like within a percentage point in each case. I looked at 3 populations, 150 individuals of Cylindropuntia wolfii. I was just amazed. I expected it to be in the ballpark, but I did not expect it to be that close. So now I'm even more anxious to get back down to Baja and find these other 2 species in flower. This is Cylindropuntia sanfilippensis. This is from right outside San Felipe, where Greg Starr and I camped back in January on our trip down there with Peter Breslin. It was way too early. They weren't even in bud yet, so John Redmond very kindly allowed me to use his awesome flower photo here. And then farther south, Cylindropuntia calmalliana. This is actually from the northernmost population of this species. This is from the same Baja trip back in January. And they were just barely starting to flower, so I was only able to get a couple of flower pictures to show you the variation. And you can see on this one, it was really kind of still in bud, and I just pried it apart so that I could get a picture of the nice red filaments. But anyway, you can see that there's variation there as well. So I'm really anxious to get back down to Baja and find those things in flower. Okay, wow, I'm going way too fast. So a question that you might be asking yourself and that we get a lot is, how did this thing go undescribed for so long? I mean, it's not some puny little annual that's easily overlooked. It's a big freaking cactus. And the answer, of course, is that it has been collected in the past. It's just, as I've alluded to, been misidentified as Cylindropuntia echinocarpa. Munz and Keck collected chuckwallensis at Corn Spring in 1922. They made 2 collections, and on one label they described the flowers as being reddish-brown, and on the other one they described them as being brownish-red. And then Jepson and Pearson collected it on consecutive days at Cottonwood Spring in what is now Joshua Tree National Park. And Pearson noted on his herbarium label that the flowers were a peculiar dull reddish purple, sometimes with a yellowish shade, which sounds really strange and makes me wonder why they didn't look into it a little more. But you know, chollas are kind of notoriously difficult to deal with, so not everybody wants to go poking around and get poked. And this is an excerpt from Jepson's field notes, which are all available online, by the way, at the Jepson website, the Jepson Herbarium website. They make for fun reading. Jepson obviously had quite an interesting personality, and and he called it Opuntia echinocarpa, and he gave it the common name quill cholla, which is not a common name I've heard for echinocarpa before. It does kind of indicate that he might have thought the spines were a little different, because they're very thin, like porcupine quills. The collection just before this was Cylindropuntia ramosissima, which he called cane cholla, which was also very strange. I've only ever heard that for imbricata and Spinosior. But at any rate, I had a lot of fun reading his notes about this trip. He and Pearson went on a several-week trip through the Southern California desert, and Jepson's notes kind of give a good picture of their relationship, and it really amused me because it sounded very familiar. In this case, right after they collected the chuckwallensis, which they called echinocarpa, Jepson wrote, "We left Cottonwood Spring in a hurry, Mr. Pearson being anxious to get along. On the gradual rise to the summit toward Pinto Basin were many fine things, but only once did we stop. Rather near the summit was one of these rich flats in the wash where desert shrubs grow to great perfection. I should have liked to have stopped and studied this assemblage for a few moments, but there being nothing new, we went on." And then a couple of pages later, he says, "Before we reached this particularly choice group of shrubs, I saw in the wash a most wonderful brandegia vine growing luxuriantly over a shrub and draping it with its greenery." Jepson was also quite a poet. Mr. Pearson saw it too. "He has a perfectly marvelous eye for seeing things even when himself driving the car at 25 to 40 miles per hour. He considers 20 miles very pokey and slow enough to see anything. As I say, he saw the drapery of brandegia, but as he had collected it, he had no further interest. My attitude was just the contrary, of course." Yeah, this sounds like about 800 conversations that Mark and I have had over the course of the Cylindropuntia chuckwallensis study. We actually drive our trucks separately, but we have walkie-talkies, so we're always having things like, "Oh, let's stop here, this looks so cool. No, we need to make camp before dark. I hate cooking in the dark. And why are you driving so fast on this dirt road? Well, why are you driving so slowly?" So apparently some aspects of botanical expeditions are timeless and universal. I got a kick out of that. So I hope by now I've convinced you that Cylindropuntia chuckwallensis is just the most awesome new species ever, and everybody is just champing at the bit to go out and find it. So where should you go to see Cylindropuntia chuckwallensis, and what are the other cool things you can see while you're seeing chuckwallensis, even though, of course, chuckwallensis is the coolest thing. As I've already alluded to, whoops, takes a little while. As I've already alluded to, Corn Spring is a very good place to go to see Cylindropuntia chuckwallensis. It's very easily accessible. It's 8 miles south of Interstate 10, south of the town of Desert Center. Just look for the big solar plant and go south. The road is dirt, but it's very well maintained. It's very wide. You'll have no problem taking your Fiat or Mini Cooper out there. There's a developed campground if you're into that kind of thing, with real toilet, well, not real toilets, but close enough. And there is more Cylindropuntia chuckwallensis out there than you can shake a stick at. It is, in fact, the only cholla out there other than Cylindropuntia bigelovii. And the cool thing about the Cylindropuntia bigelovii out at Corn Spring, although you can't tell it just by looking at it, is that they have diploids out there. This is interesting because bigelovii is generally triploid. And Mark has been working for many, many years, and I've just been helping in the past few years, in mapping the chromosome races of Cylindropuntia bigelovii. The reason that diploids are so important, of course, is that triploids generally cannot reproduce by seed. They can't reproduce sexually. They just have to clone. They drop off joints. And we all know how good Cylindropuntia bigelovii is at that. That's why the other common name for it is jumping cholla. And so it's very well adapted to spreading by joints wandering around and falling off various places. But these diploids represent a really important little occasional injection of genetic variation into the populations. And that's really important for things like spreading into new niches, for example, under global climate change. So we are really interested to look into this and get these things mapped. Interestingly, this has nothing to do with chuckwallensis, but it's still cool. A couple of years ago, a hiker found a population of Cylindropuntia bigelovii in Panamint Valley, just west of Death Valley. And it's the northernmost known population of bigelovii by quite a bit. In California, it's the northernmost known by quite a bit. Over the entire range of the species, it's still the northernmost, not by quite as impressive an amount, but and so we've been out there now a couple of times, and we have found diploids out there, so at the edge of the range. And several of the other diploids that have been found are also on the edges of the range, which is kind of what you would expect in the places where things are spreading. So yeah, as far as the diploids in Corn Springs, we were camped in a wash several miles past the campground one morning eating breakfast or whatever. And Mark says, "Those biggies over there look like diploids." And I said, "Whatever, man." Went back to eating my breakfast. So he goes marching over there and he grabs Bud and comes and puts it under his microscope, and boom, it's a diploid. One of these days I might learn to stop questioning him when he says things like that, but I'm eternally skeptical, which tends to be kind of useful most of the time. Maybe not when dealing with Mark Baker. When it comes to cactus. The absolute strangest thing at Corn Spring is Lophocerius shottii. Now this should shock you. This was found a couple of years ago by a California Native Plant Society hike group that was hiking out there looking for rare plants, and hey, boy did they find one. This is a new record for California, and it represents a range extension of over 140 kilometers north for this species. The only other place it occurs in the United States is down in Organ Pipe National Monument on the Arizona-Mexico border. Once you get down into Mexico and Baja, it's very common. But these things are strange. It's really strange to have found this here. I can't emphasize that enough. Unfortunately, only 2 individuals were found. And one of them, the one that you see me standing here, is mature. It flowers like crazy. The other one is immature. It has not started flowering yet. We have no idea whether these plants represent the last dying gasp of a relict population. This part of the desert is very well known for having a high number of relict species present. So that's one possibility. The other possibility is that it's an escape from horticulture. Corn Springs was used for mining for up until the mid-'80s, I believe. There is still a dilapidated kind of set of, broken down trailers and things a couple miles up the wash at a place called Aztec Well, and where there are quite obviously planted saguaros and various other things. We have not seen any Lophocerius shottii in there yet. We did go back there. There is one house that is still at least semi-occupied, and we happened to be there on a day when the homeowner was there. And Mark, being the brave man that he is, actually went up and talked to him about these things, and he was not friendly. Not friendly. He didn't pull a gun on us or anything, but he was not interested in talking to us. He did know about these plants, and he did say that in his 25 years of hiking around in the hills, he had not seen any other than these two plants. So that was useful. And we said, thank you, and left. We have tried with binoculars and Google Earth to like look down in there and see if we can see any little Lophoceriuses under the overgrown tamarisk and acacia and mesquite and all that down there. But we're not going to go wandering around down in there. But who knows what could be hiding down there? So it could be an escape from horticulture. And then the other possibility, one other possibility, is that it could have been transported by native people before the miners showed up. Many tribes used the Corn Spring area both as a migratory route, and there were also, of course, non-nomadic tribes that lived there, obviously because of the spring. And we know that the native people down in Baja used Lophocerius schottii for several things, so it's entirely possible that it got traded and ended up there that way. We just don't know. And I guess genetics would be the first way to kind of look into it, but you know, for a possibly doomed population, there's probably not going to be funding for that. Both of these plants, unfortunately, are very easily accessible. They're very close to the road. They're very close to each other. They're within a couple hundred meters of each other. And they have both had multiple stems removed, we assume by unscrupulous people collecting it for horticulture. If you want to go to Corn Spring and you want to see these, I will tell you, but I might do a background check on you. Just be warned. One good thing, one piece of good news about these guys is that they have put on a lot of growth in the past couple years. We've had a couple of good summer monsoon seasons out there. We've had some decent spring and winter rains. So there is a good chance that this immature specimen will start flowering at some point, and there will be the potential for outcrossing. This species is an obligate outcrosser. It takes two to tango. Unfortunately, the vast majority of its pollination and seed set is mediated by one particular moth species that lives on the cactus its entire life, very similar to the yucca moths and the Joshua trees. So if you have no outcrossing, which obviously we don't have at this population, this mature individual, as I said, it flowers like crazy. There's absolutely no sign that any fruits have set any time in the recent past. It can also, however, the group at University of Arizona that has studied this symbiosis between the Lophocerius schottii and the moth, they found that about 80% of its pollination and seed set was done by this moth, but they also found about 20% was successful seed set by halictid bees, and halictid bees have actually been collected at Corn Spring in the past. So if that immature individual starts to flower, there is a very, very, very small chance that there could be some outcrossing. There'd be a way bigger chance if somebody wants to go out there with a little paintbrush and cross-pollinate, which I'm tempted to do, believe me. Anyway, further surveys to find more of these plants out there would be awesome. Lots of people that I know have been out crawling around in those hills looking for more. We've all been unsuccessful so far, unfortunately. This kind of interesting picture is a spur-of-the-moment little experiment we did one night. We got to Corn Spring around dusk, and Lophocerius schottii is a nighttime flowerer, as you might expect by a moth-pollinated species. And we happened to have a wildlife camera with us, because why not? So we commandeered a trash can from the campground, and we duct taped the wildlife camera to the ironwood tree branch, pointed at the flower in the vague hopes that we might catch a moth or a bat or something trying to pollinate it. Unfortunately, it was a really windy night, and so we just ended up with a bunch of blurry photos until the camera fell out of the tree. What can you do? All right, enough about Corn Spring. Another really awesome place to see Cylindropuntia chuckwallensis is Joshua Tree National Park. If you have not been to Joshua Tree National Park, which I have a hard time believing anybody in here hasn't, you need to go, like now, or not now, but at the end of the conference. Joshua Tree National Park is the first place I ever went to the desert. I fell in love at first sight, as it says in my little bio blurb. The Joshua Tree National Park is the reason that a large part of the reason why I became a desert ecologist and a desert botanist. It's just absolutely fabulous. I can't say enough about Joshua Tree. The easy place, one of the easy places to find Cylindropuntia chuckwallensis at Joshua Tree National Park is down in the south end of the park at Cottonwood, near Cottonwood Spring. This is Cottonwood Spring out here. You can see the palms and the cottonwoods. And in the back here we have the Eagle Mountains. Now we have not ourselves been to the Eagle Mountains yet and seen it, but one of the park botanists, Mitzi Harding, did a rare plant survey out there a couple of years ago, and she knew prior to the survey, she knew about chuckwallensis. We had told her about it, we had sent her lots of pictures and asked her to be on the lookout for it while she was working out there in Joshua Tree. And she reported back to us that there was a whole bunch of it up there in the Eagle Mountains, so one of these days we'll have to get up there. But the easy place to see it is Cottonwood Spring. So the visitor center at the south end of Joshua Tree is Cottonwood Visitor Center, and if you take the road to Cottonwood Spring, there's a big parking area and there's a big staircase that goes down almost to the spring. If instead of going to the left and going to the spring, you go to the right and you follow the canyon down, you will find lots and lots of chuckwallensis in among the rocks, not down in the wash itself, but up in the rocks around the wash. So that's a nice, easy place to find it. Also, if you drive a little farther north through the park road that runs north-south all the way through the park, 2.4 miles north of the visitor center, there's this very obvious quartz outcropping. Ooh, it's getting dark. Although I've been told recently by somebody on Facebook that it's not quartz, it's plagioclase feldspar. Whatever it is, it's very obvious. It's a big white hill, all right? So as you're driving north, it's on the left-hand side of the road. There's a little pullout, and it's less than a kilometer hike over to the little hill. As you can see here, the chuckwallensis starts in a little bit before you actually get to the hill itself. Once you get up to that hill, there's lots of chuckwallensis, and there's also echinocarpa. So you can practice your skills in distinguishing the two species. There is also up there Coryphantha alversonii, which is a California rare on the California rare plant list. A very adorable little cactus with beautiful pink flowers. Now, I know I always make electronics go crazy, but geez. Somebody leaning against the switches? Okay, anyway, Coryphantha alversonii. If we could get those upper lights turned off, that would be great, because it's kind of glaring out the top part of my, thank you. That's all right too. Just don't fall asleep, okay? I'm almost done, All right, anyway, as I said, I do kind of have a chaos field when it comes to electronics. Anyway, there's also Dudleya. There's also a Dudleya species. I don't remember exactly what species it is, but it's up there on that quartz outcropping. If you continue north through the park, there's a road that goes off to the west called Geology Loop Tour Road. If you go to the right instead, I believe it's toward a place called Queen Mine, you're basically at the neotype locality for Grussonia parishii. And then if you continue along the hiking trail towards Queen Mine, there's a bunch of it on both sides of the trail. I am very fond of Grussonias because I think, as you can tell by their common names like dog cholla and dead cholla and matted cholla, it's an underdog, right? It's kind of ugly. You can't really deny it's kind of ugly. But like most cactus, it produces these gorgeous flowers. And so I've come to really, really like a lot of the Grussonias. Mark and I have worked on several of the Grussonias, collected a rare one out in Nevada, for a genetic analysis at Desert Botanical Garden and so forth. So I like parishii and all the others. This is also on the California rare plant list. Also out at Joshua Tree, we have Echinocerius mohavensis, one of the many taxonomically maddening members of the claret cup cactus group. Mark has done a huge amount of work on the claret cup cactuses. A lot of these used to be lumped under Triglochidiatus, but that's more correctly applied to the plants towards the east side of the range of the claret cups, over and towards New Mexico, eastern Arizona. The plants that have very few spines, thick spines, angular, smooth spines. The ones over here on the western end, especially in Joshua Tree, are very typical Echinocerius mohavensis. They have many more spines, they're thinner, They are curved. They tend to be, they're almost always curved to some degree. And they're also, if you get really enthusiastic and you look at it under 30 times magnification, the spines on Mohavensis are papillate. They have little bumps on them. So whatever you want to call it, it's wonderful. I love this species. I like it even when it's not in flower. I think those, you know, compact spiny clumps are just absolutely gorgeous. But the flowers, of course, blow them away. All right. If you want a little more of a challenge in your search for Cylindropuntia chuckwallensis, the Bradshaw Trail is really, really awesome. It's an old military route that begins south of Blythe, and it goes along south here, south of the Mule Mountains, then down south of the Little Chuckwallas and the Chuckwallas. It's a pretty good road. I recommend not taking your Fiat or Mini Cooper out there. You do want some clearance. There are a lot of, you know, washes and things like this. But in general, it's a pretty good road if you have an adequate field vehicle with all-wheel drive or four-wheel drive. The Chuckwallensis starts up around the intersection of Graham Pass Road and Bradshaw Trail. If you don't want to drive the entire 100-some-odd miles of the Bradshaw Trail and you have a decent vehicle, Graham Pass Road is actually a really cool, fairly easy way to get between Interstate 10 and the Bradshaw Trail, and you'll see lots of cool stuff. This four-wheel drive only exclamation point up here on the north part of it is because it's sandy. There are some sandy areas out there. But in general, if you have a good vehicle, it's a easy road. It's a pretty easy road. Like I said, Chuckwallensis comes in around the intersection here, and it's kind of all along Bradshaw Trail. It also goes up Graham Pass Road until you start to get into the actual mountains there, and then it quickly peters out. But if you take Bradshaw Trail, your reward is seeing a lot of other really neat cactus, including one of my personal favorites, Cylindropuntia munsii, also on the California Rare Plant list. The last time we were out there just kind of bopping around looking at stuff, we said, hey, let's just measure some Mun's Cholla just for the fun of it to have the data. This was our champion. It's over 3 meters high, over 3 meters wide. You're not going to mistake this one for anything else. This is a really cool species. It gets down into Baja, but it's fairly rare in California. Really nice kind of weird bronzy colored tepals on the flowers. Nice one. And of course, anywhere where you have multiple Cylindropuntia species, you're going to find hybrids. The Cylindropuntia are very promiscuous. They'll happily breed with each other. We're pretty sure that this beast here is a hybrid between Echinocarpa and munsii. We found it with all three in flower, so we have Echinocarpa, munsii, and the hybrid. Unfortunately, or it doesn't really matter, but they're all diploids. Sometimes with hybrids, you know, if the parents have different ploidy levels, chromosome numbers, you can look at the hybrid and you can be like, oh, it's that number, so these have to be the parents, like in Puntia charlestonensis. That's not the case here. They're all diploid, but munsii and Echinocarpa were the two that were nearest this thing. So, and Mark and I both have stems of this one growing in our yards. There's other neat stuff out there that's not rare, but it is just fun to look at. Echinocactus polycephalus, cotton top cactus. Mark Baker is not a short individual. So this is a very, very large clump, probably one of the biggest clumps that I've ever seen. This one has some really amazing long spines. This one had tons and tons of that cotton that's produced around the fruits. We joked that I could probably knit a whole new cactus out of that. Ferrocactus cylindropuntia, barrel cactus. Everybody loves barrel cactus, you know, one of the just prototypical southwestern desert plants. And there's also a lot of Mammillaria tetransistra, which it's hard to find if it's not in flower or fruit, but when it is, it's fairly easy to find. I can never decide whether I like it better when it's in flower or fruit. The flowers are so beautiful, but these fruits just always crack me up. They look like giant clown noses or something. They're great. I love this species. I have a lot of that in my yard also. So we all need to be propped up sometimes. So I wanted to give props to everybody who helped us. We did not get any formal funding for this study, but of course every company and agency that hired us in these few years that we were working on this indirectly funded it by giving us gas money and stuff. URS is the company that we were working for when we discovered it, the very safety/liability conscious company. And I like to make fun of them for that, but they're really a great company to work for. John Redman at the San Diego Natural History Museum and Mark Porter right across the street at Rancho Santa Ana Botanical Garden reviewed our paper and made it much better. By the way, I have to give a plug here for Rancho Santa Ana. Everybody needs to get a chance to go over there. It's an incredible botanical garden. It's a wonderful, wonderful place. I can't say enough about the garden, the people who work there, the grad students who probably work there harder than anyone else because they're grad students. Jim and Tasha out at the Granite Mountains Research Center in the Mojave National Preserve gave us a lot of good discussion, and Tasha, who works for Joshua Tree, also brought us specimens from the Joshua Tree herbarium so that we could annotate them correctly. Mitzi, I already mentioned. Mike helped us with permits for Joshua Tree. Jason is actually the guy who informed us that chuckwallensis was in Joshua Tree. He and Mark were working on a project together in southern Nevada, and so of course the topic of Cylindropuntia multigeniculata came up, and he said, you know, I think I've seen that in Joshua Tree. And Mark said, well, you probably didn't. What you probably saw was our new species. Do you have UTMs for us? And he did. So we went and found it at Cottonwood Springs. Andrew Doran up at UC Berkeley Jepson Herbarium sent us images of Jepsons. Historical specimens. We actually got a chance to get up there in January during the CNPS conference, and we are pretty confident at this point that we have annotated all of the historical specimens to Cylindropuntia chuckwallensis, the ones that should be. I noticed the other day that the annotations are either not in the California Consortium of Herbaria website yet, or there's actually a couple mistakes on a couple of them, so I need to deal with that at some point. But we are pretty confident that all of the physical specimens have been correctly annotated at this point. As far as the Lophocereus goes, we had lots of cool discussions with lots of people, CNPS, Andy Sanders at UC Riverside, and lots of people over at Rancho Santa Ana. Another plug for them. So if you want to know about Cylindropuntia chuckwallensis in absolutely excruciating detail, we published it in Madronio last year, so it's available through Madronio's website if you have access to that. If you do not, please see me. I'll be here the rest of the week. I have business cards with my email address, and I would be more than happy to send zillions of people PDFs of our paper. I am always very pleased to spread the gospel of the Chucky Cholla. And with that, I'd be happy to take any questions. Thank you. How'd I do? Yes. Yes.
Can you say anything about fruit from this new species?
Yeah, we have collected a little bit of fruit. It's really hard to get out there before the rodents get to it. We have managed to collect a little bit of seed. I tried to germinate it, but I don't really have a good germination setup. I don't think Mark has tried to germinate it yet, but they look like they're viable seed. I mean, they look nice and healthy and filled and stuff like that. So hopefully this summer maybe we'll get a chance to try to...
So then you've seen flowers with antler?
Well, that's another thing that we want to look at. We do have plants marked as to whether they're perfect or female flowered, and at some point we want to get out there in the right amount of time so we can collect fruit from both and compare the seed set to them. We just haven't had a chance to get out there. Spring is the really busy time, and so the time that we should be out there collecting is when everybody is actually paying us money to do botany, and we kind of have to take that where it comes. Steve?
I did a veg survey for WAPA north of Blythe a few years ago.
Mm-hmm.
Now you've intrigued me. Now I want to go back and look at that population.
Do it.
I thought at that time, that's a different echinocarpa, but like everybody else, yeah, it's just.
I will come with you. Let me know when you want to do that.
It's a very cool spot because there's a lot of alversonii in that area.
Oh, so is that on like Highway 95 north of Blythe?
Yeah, just to the west along the WAPA power line.
I've seen that alversonii out there. Yeah, it's pretty impressive.
And there's a low cholla there.
Yeah. Yeah. Cool. Yeah, let's do that sometime. Sir?
It appeared in your pictures that the reddish pinch flowers were predominantly male, or had no pollen, and the yellow flowers always carried the pollen. Is there any, do you have a theory of why that's?
I've actually looked at the numbers on that, and there does not appear to be at this point with the data that we have. It doesn't appear to be significantly different between the flowers. there are so many fewer of the yellow flowers that, you know, if you take 63% of those, you know, most of them are going to end up to have pollen. So I need to run some better statistics on it, and I do want to get more data on that as well. But at this point, it doesn't look like there's a significant difference in perfect versus female flowers as far as flower color is concerned. Now, that's a great question.
That was the same. I was correlating. The reds looked like they had less.
All right, yeah.
pollen.
Yeah. Sir?
In one of your maps, you showed a location of chollas that looked like the Cargo Muchacho Mountains. Do you remember what species?
The Cargo Muchachos, that probably would have been an Acanthocarpa. Oh, was that the picture with the Acanthocarpa for the morphology study? Because that was one of the places that we measured Acanthocarpa was right near the Cargo Muchachos, yeah. And we did look up in the Cargo Muchachos for the Cylindropuntia chuckwallensis, but we didn't find it up there. So, really, sir?
Before that you were discussing, I know you don't have genetic data. I think you heard you're going to do for the future, but based on the physical morphology, which do you think is basal?
Probably if I had to, I shouldn't even put out at this. Probably Acanthocarpa because it's diploid would be my guess. But we don't have any data yet. We're actually, Mark and I have been talking, I don't know, he might even be here, to Lucas Major at DBG, the Desert Botanical Garden, and he's who we will be working with hopefully in the near future to do genetics on these things. Not just chuckwallensis, but as many of the Cylindropuntias as we can possibly do. Yeah. Anybody else?
All right, thank you very, very much.